What would you guys like to see on the review? Yes. You could say that, but I think there's probably another pattern that you could find. If it's adding itself, what's happening? It's doubling. There you go. All right, so we're going to start with number 4. This one right here where it says, if B is the midpoint of segment AC, then AB equals AC. And that conclusion there is saying that the length of segment AB is equal to the length of segment AC. So our hypothesis is everything that comes after the word if. So this is what I'm going to write on the line for the hypothesis. Remember, on the test, you cannot just underline and label. You have to rewrite this. You'd write B is the midpoint of segment AC. And our conclusion is everything that comes after the word then. So this equation right here would be my conclusion. The length of segment AB is equal to the length of segment BC. Then it says to state the converse. What was the key word that we used for converse? Does anybody remember? Switch. Inverse is not, converse is switch, and contrapositive is both, not, and switch. So for my converse, we're going to take the hypothesis and the conclusion, and we're going to switch them around. So now it would be if the length of segment AB is equal to the length of segment BC, then B is the midpoint of segment AC. D, is it possible to write a biconditional for the conditional? If so, write the biconditional. If not, explain why / give a counterexample. So a biconditional first has the hypothesis, and then it has the words if and only if, and then the conclusion. But you can only do this if the conditional is true and the converse is true. So it didn't explicitly say we needed to find the truth value of both our conditional and the converse, but we need to. So let's go up and evaluate our original conditional. The original conditional says if B is the midpoint of segment AC, so I'm going to draw this segment here. Here's A, here's C, and if B is the midpoint, then segment AB would be congruent to segment BC. Or sorry, segment AB and BC have the same length. So this one would be true. However, the converse is false. The converse is false. And to show why it is false, I'm going to draw a counterexample. So on my converse, I need to draw a picture where this is true. But the conclusion is false. So I need to draw a picture where segments AB and BC have the same length. So something like this. Here's my segment AB and my segment BC. AB is the same length as BC. And then I do need to draw in segment AC because it says B is the midpoint of AC. B is not the midpoint of segment AC because B is not even on segment AC in that picture. Remember, a counterexample means I need to come up with something that makes the first part true, but the second part is not true. And the only way to make that happen on this particular converse is to draw where AB and BC are not all collinear. A, B, and C are not all collinear. What else would you guys like to see off of the review? Number 8, absolutely. Let's go to number 8. There we go. For number 8, we need to write down what postulate, property, theorem, or definition allows us to make this statement right here. When I look at the picture, Ki, or the length of Ki, this is a segment. IA is also a segment. And KA is the largest segment in the picture. It is the segment addition postulate. You're absolutely correct. What else would you guys like to see from the review? Yes.
Would you accept it if I wrote?
Like numbers, number 1 parts A and B?
Yeah. Would you?
Yep, I would accept that.
Alright.
Absolutely. Yes. Number 12? Absolutely. Number 12 says if the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, and the measure of angle 3 is equal to the measure of angle 4, then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 equals 180 degrees. So if I look at everything that is part of my if, this right here, I notice that I have this big long equation that is equal to 180, which is similar to what I have back here, but there's been a change. Here in my if, I have the measure of angle 3 as the third angle, and in my then, We have the measure of angle 4 in its place. Measure of angle 1 plus measure of angle 2 stayed exactly the same, so there was no change there. I'm just looking at the pieces that changed. Angle 3 came out, and angle 4 went in. We were told right here that angles 3 and 4 are the same size. What allows me to take something out of an equation but put something of equal value back in its place? Substitution. What else would you guys like to look at? Number 24? Absolutely. 24 is the very last problem. Very backside problem. We have a flowchart proof here. We are given all of the statements. We need to provide all of the reasons. This statement right here is my given information. And so my reason that I can make that statement is because it was given to me. This other top level statement over here can't be coming from my given because I only had one thing in my given. So it has to be coming from something I'm allowed to assume from the picture. So let's go find angles 1 and 2. Here's those two angles. What do we call that angle pair? Vertical angles. And this is saying that they are congruent to each other. So I'm going to go ahead and mark them as congruent on the picture. Vertical angle theorem, yes. I'm going to mark angles 2 and 3 as congruent since that was my given. So then I get here to this second level. It says angle 1 is congruent to angle 3. Well, angle 1 was right here, and angle 3 is right here. What are angle 1 and angle 3 both congruent to?
Angle 2.
They're both congruent to angle 2. So I have two objects, two angles, that are both congruent to the same thing. That is my transitive property. You could use substitution there, but technically speaking, what we've got is the transitive property. I would accept either one is correct, though. Yes. So the transitive property, do you see how I have angle 2 right here, and I have angle 2 right here? The transitive property means I have three things, and they're all the same size as each other. So here, angle 3 is the same as angle 2, and over here, angle 1 is the same as angle 2. So I'm going to take the one that is repeated, angle 2, out and put the other two pieces congruent to each other. So we take the middleman out there. All right, so there's my transitive property. Down here also on this middle level is this guy. Does he have anything above him? No, so technically he could go up on the higher level. He's just not there because that's where my picture is. But he doesn't have anything above him. So again, if there's nothing above it on a flowchart proof, it has to either be coming from your given information or from the picture. So this must be coming from my picture. Since it can't be coming from my given was already over there. Angle 2 is congruent to angle 3. So let's go find angles 3 and 4 in the picture. Here's angles 3 and 4. What is their relationship? They're a linear pair. The reason I'm allowed to say that they're supplementary to each other is the linear pair theorem. All right, and then my very last statement, the thing that I'm trying to prove, it says angle 1 is supplementary to angle 4. Well, when I look at the statement that we were just focused on, it says angle 3 is supplementary to angle 4. Everything after that first angle name stayed exactly the same. But we traded out angle 3 and we replaced it with angle 1. So that would be the substitution property. What else would you guys like to see? What else would you guys like to see off the review? Yes.
Could you do 23?
23, absolutely. Remember that very last step on number 23, you needed to add at the bottom because it accidentally printed on the next page. So it should end with the thing that we are trying to prove. My first statement here needs to come from my given information, and they even told me that that was my given. So we have segment XY is congruent to segment WU, and segment XZ is congruent to segment ZU. Let's go mark that on the picture. XY is right here. WU is right here. Those are congruent to each other. XZ is this whole segment here. And ZU is this whole segment over here. And we're saying that those are congruent to each other. They told me that my second reason was definition of congruent segments. And right here, I have some segments that are congruent. According to the definition of congruent segments, if I already know segments are congruent, what does that mean about them? Yes, their measurements are equal. So I would have the measurement of segment XY is equal to the measurement of segment WU, and the measurement of segment XZ is equal to the measurement of segment ZU. And then we get to our third statement right here, where it says XZ, that's this whole big long statement here, is equal to XY, this segment, plus YZ, this segment. What is it that allows me to take two smaller segments that are touching each other, put them together, and get a larger segment? Segment addition postulate. And that's the same thing that's happening with that other equation, ZU. This segment is equal to ZW plus WU. So segment addition postulate. All right, now we have the substitution property coming in. And it says I'm going to use substitution property here now twice. So the first substitution that I think I want to make is taking all of this right here and replacing XZ with that, because it's equal to XZ. And at the same time, I'm going to take ZW and WU and put it in the place of ZU. So I have XY plus YZ is equal to ZW plus WU. I made that decision. I knew that that was the substitution that I wanted to make here, because looking at where I'm trying to get to, I need YZ and I need ZW, because both of those are part of where I'm trying to get to. So I had to have an equation that had YZ and ZW in it. I had this equation had YZ, this equation here had ZW, but I didn't have an equation that had both of them at the same time. So that's the first thing I needed to do, was get an equation that had both of those at the same time. And now what I want to do is I want to get rid of the XY and the WU so that I just have this part left, because that's what I have right here. What allows me to get rid of things? What operation lets me get rid of stuff? Subtraction. But to use my subtraction property of equality, I have to be getting rid of the exact same thing on both sides. Is what I'm trying to get rid of on both sides exactly the same? No. But what do I know about WU from my second statement? Yeah. WU is congruent to XY. So I'm going to put XY in the place of WU. So I would have XY plus YZ equals ZW plus XY. So that's my other substitution that I'm making here. And then I already mentioned what we want to do next. I want to get rid of the XY on both sides, and you guys already told me that what will allow me to do that? Subtraction property of equality. And now we just have our very last statement to make. Somehow I have to go from the statement here, where I'm saying the segments have the same measurement, to this last statement where I say that means they're congruent. Definition of congruent segments is absolutely correct. Nicely done. What else would we like to look at? Yes. Number 21? Absolutely. All right, so in number 21, it says, using the figure to the right, if the measurement of angle LKJ is 137 degrees. Before I read any further, I'm going to go add that to my picture. L is right here. K is right here. J is right here. So when it says angle LKJ, that's this whole thing right here. That is 137 degrees. Says that the measurement of angle PKJ is x plus 5. P to K to J. So this right here is x plus 5 degrees. And then LKP, L to K to P, is x plus 90 degrees. Find the value of x and the measurement of angle LKP. How many angles are in the picture? 3. Talk to me about their relationship to each other. They're not the same size. The two smaller angles are not the same size, but we do want to focus on the two smaller angles. What's true if I put those two smaller angles together? Gives me the bigger angle. Angle addition postulate, yes. So we're going to use our angle addition postulate. What are the names of the two smaller angles? PKJ, so the measurement of angle PKJ plus, what's the other smaller angle?
Measurement of LKP.
Measurement of angle LKP. And when I put those two smaller angles together, what's the name of the larger angle? LKJ, so equal to the measurement of angle LKJ. And now I can make my substitutions. In the place of PKJ, we're going to put in x plus 5. Drop my plus sign down here. In the place of LKP, we're going to put x plus 90. And in the place of LKJ, we're going to put 137 degrees. So now I'm going to solve this for x. First, that means I need to combine my like terms together. So I have x and x, which gives me 2x. I have a positive 5 and a positive 90. That gives me 95. So 2x plus 95 equals 137. Now I subtract 95 from both sides. What is 137 minus 95? 42. And then we divide both sides by 2. What is 42 divided by 2? 21. So x is 21. LKP, we got to plug back in. I think you're right. Measurement of angle LKP is x plus 90. We just figured out that x is 21. So I have 21 plus 90, 111 degrees. And then there's a part B on this problem. It says, what postulate theorem property did you use to set up your equation? Well, what did we say we were using back at the beginning? Angle addition postulate. Have time for probably 2, maybe 3 more problems. What else would you guys like to see? Number 6, absolutely. Number 6, that's part C. Let's go to number 6, part A. Find the following using the given conditional statement. Converse means we are going to switch. Or sorry, that's part B. How did I get to part B? I want part A. I thought I had part A up on the screen. I'm sorry. Converse means we're going to switch. So when I look at this conditional statement, it says if two angles are a linear pair, so there's my hypothesis, then they are supplementary. So there's my conclusion. So we're going to flip that around the other way. If I don't want to say they are supplementary. What does the they mean here? Two angles. So if two angles are supplementary, then they are a linear pair. All right, now we got to think whether that is true or false. If I have two angles that are supplementary, what does supplementary mean? They add up to 180. If I have two angles that add up to 180, do they have to be a linear pair? No, so this would be a false statement. If it's false, then we have to give a counterexample. So for my counterexample, I want to make the first part true. I want two angles that are actually supplementary, but they do not make a linear pair. What does a linear pair look like?
They're adjacent.
They're adjacent, so they share a side, they're touching. Could I draw supplementary angles that are not touching? Yes, so that's what I'm going to do. I'm going to draw two angles that do not touch each other, but still add up to 180 degrees. So here's my two angles. To show that they're supplementary, I have to provide the angle sizes there. Let's see, let's pretend that this angle right here is 30 degrees. If that's 30 degrees and these angles are supplementary, how big would the other angle have to be? 150 degrees, because 150 plus 30 equals 180. And that's what I needed it to add up to. All right, so that's part A. Now we're going to do the inverse. If converse is the one where we switch, what is inverse? Not necessarily false. The inverse is not. So with my hypothesis, I need to put a not in with my hypothesis, and I need to put a not in with my conclusion. Everything else about the order of my original conditional statement stays exactly the same. So my statement would become, if two angles are not a linear pair, then they are not supplementary. And we are asked to evaluate the truth statement of this. Now, before I decide whether this is true or false, I need to remember what's true about my conditional, converse, inverse, contrapositive, because that'll help me with this. If the original conditional statement is true, then the contrapositive is true. If the original conditional statement is false, then the contrapositive is false. Those two always will have the same truth value. The same thing is true about my converse and my inverse. If the converse is true, the inverse is true. If the converse is false, the inverse is false. Was our converse true or false? False. So this inverse would have to be false. But let's read the statement to understand why it's false. We're going to need to provide a counterexample for this. It says if two angles are not a linear pair, then they are not supplementary. So if I can think of a pair of angles that are not adjacent, they're not a linear pair, but they are supplementary, then that would make this false. Didn't I have something like that drawn for the converse? I had two angles that were not a linear pair, but they were supplementary. So I can redraw the same basic counterexample here. So I could have a 30-degree angle and a 150-degree angle. These are not a linear pair, but they are supplementary because they do add up to 180 degrees. And then we have our contrapositive. With a contrapositive, we do what? Not, and switch. So I'm going to come back here. I'm going to put my knots back in here. But now I need to flip it around. This right here is my new hypothesis. And this back here is my new conclusion. So this would become, if they, what's they again? Two angles. If two angles are not supplementary, then they are not a linear pair. If I have two angles that don't add up to 180, can they be a linear pair? No. So this statement is true. And my explanation here would be that linear pair angles always add to 180 degrees. They are supplementary. All right. So I said I had time for probably two more problems. This one, though, had three parts to it, so it kind of ate up all the time that we had. I do want to show you guys where you can find the answer key, because just like in the past, I have posted that on Canvas, and it's up already. Today's date. So we're going to scroll down until almost the bottom of this module. It says Wednesday, 9/18, review for Module 3 test day 2. You have to click on that page. And then once you're on this page, you're going to scroll all the way to the very bottom, right down here where it says Module 3A Test Review Key PDF. And if you click on that, it pulls up the entire test review key here. Everything is worked through. Also, I will be posting the videos from every single one of my class periods today. So I would highly encourage you to get in and check out the periods 2, 3, and 7 videos if you had questions about problems that I did not go over. And please don't turning in that test review tomorrow. It does need to be completed. I only grade the test review for completion, so you have to go through and do every single problem.